Neuromatch conference. Let me introduce myself. I am Nur from Yeditepe University, and I'm going to present our study titled Machine Learning Based Morphology and Emotional Analysis in Turkish Sign Language. Let me start by showing the outline of the presentation. Initially, I will talk about emergence of sign languages, and later I will explain the experiment which seeks for a relationship between sign language morphology and emotional sentiment content. Then I will talk about our second experiment, which compares the emotional face expressions in signers and speakers. And finally, I will discuss our results. Sign languages are among the earliest forms of communication in humans. One of the most important questions that strike linguists are how does a language come about and how do the properties of human language get their start from scratch? Previous literature on various sign languages suggests that signers, users of a sign language, can decode emotions like happiness, anger, neutrality by following hand movements or facial expressions of signers. Motivated by the findings of this previous literature, the goal of the first experiment is to use machine learning to detect morphologically distinctive patterns in Turkish Sign Language based on emotional valence of lexical items. For this purpose, we decided to detect hand movements in the videos containing the words Turkish Sign Language native signers. Thus, we could examine whether there is a relationship between hand movements and emotions. So we used the Contemporary Turkish Sign Language Dictionary, consisting of 1971 videos that demonstrate individual signs for the morphological analysis of signs. It's a corpus-based dictionary. All models in the videos are native Turkish Sign Language signers. And we use Senti-TurkNet for sentiment polarity of concepts that target signs correspond to. Senti-TurkNet is a lexical resource that was created with machine learning algorithms. It contains polarity scores, part of speech tag, and glosses for Turkish words. Polarity scores are between 0 and 1, and they labeled as positive, negative, and objective. First, we applied drawing bounding box method to obtain spatial coordinates of hand movements from the target signs. There are 7 steps needed to draw the bounding box. Firstly, 2 frames extracted from the video. The difference between these 2 frames means movement. Then Gaussian blur is applied for eliminating the noises, and dilating function is applied to get rid of small weak threshold lines for healthy threshold detection. Contours from a clean threshold are found, then small contours are eliminated, and finally rectangles drawn for each detected contour on the frame. Each bounding box has x and y coordinates of the 4 corners and the width and height values which we use to feed model for sentiment prediction. We also use a standard deviation of x and y coordinates during signing to calculate how much people move their hands in the signing space. Signing space is the area where the sign is made by the signer. They use the area around their bodies. We also use Euclidean distance of weight and height values of the bounding box to calculate the spatial extent of the signs. We then use multiple regression to predict the sentiment polarity of target sets. The results of the multiple regression for the objective words reveal an R-square of 0.8, indicating there is an 80% possibility that there is a relationship between hand movements and objective emotions. However, the R-square was as low as 0.2 for positive word category and 0.02 for negative words. As you can see, the root mean squared error was below 0.2 for all sentiment polarities. In experiment 2, we compared the use of facial emotional expressions such as happy, sad, disgust, neutral, fear, and surprise of signers and speakers for 8 syntactic categories. Again, we use contemporary Turkish Sign Language Dictionary. We also created a spoken language video database in order to compare the facial expressions of signers and speakers. For this database, we recorded the videos of an individual who uttered the same words signed in the contemporary Turkish Sign Language Dictionary. In order to compare facial expressions in both language modalities, we used a convolutional neural network model to detect facial expressions. An analysis on all words in databases revealed that signers expressed sad, surprised, fearful, and disgust emotions more intensely. The only exception is that speakers use happy emotions more intensely. The use of natural expressions was the most dominant among all words and balanced between signers and speakers. The results for the use of facial emotion expressions per syntactic categories show that, in particular, speakers use more happy expressions for conjunctions and both happy and surprise expressions for prepositions. Our results suggest that in some cases, the spatial use of gestures and facial expressions of Turkish Sign Language signers could predict the emotional content of signs and syntactic categories. One limitation of our study was the unbalanced number of positive words and negative neutral words, which is an obstacle for the classification algorithms. In the future, larger databases can help us to operate over sufficient number of inputs for both the train and test phases. Further research might be focused on utilizing an extensive database can confirm our findings about spatial patterns of signs and use of facial expressions, which could be informative about how signs emerged morphologically. Thank you for listening, and I'm looking forward to your questions and comments.